My grandma was good.
Okay, we know where they're at. Okay, so looking at, I wish I could move my pictures. They're making me mad. Why can't I move my pictures anymore?
It looks like your screen is blinking at you.
Oh, looks like your screen.
I'm glad that.
No, this always does,
worst
but my
part was
thing's not
the numbing
responding.
shot for the epidural. That was the worst.
Are you connected to
That makes,
But
yeah,
then after
that
that,
works. Okay, well, so you need to know that there are portions to the kidney itself. When we talk
I'd
about,
rather have a baby than you.
I'm trying to think if we've talked about any other things that have crust and middles. Don't recall, but we'll talk about some adrenal glands and we'll talk about some other stuff that is similar to this. But the kidneys themselves, we have a crust. If you think of like an orange, and this would be the rind of the orange, and then this middle part would be the part that you eat. So crust is your renal cortex, and that's why I say crust, because it starts with a C. So renal cortex is all this little section out here. It's going to be important in just a second. The middle portion that we eat is the renal medulla. So the middle, renal medulla. So we have renal cortex and renal medulla. You're going to have to know what structures are found in those areas.
You said that we eat.
Yeah, like an orange. You got to be listening. So if you start out, we're going to talk about urine formation and all these structures that it goes through. Right now, we're just looking at the kidney. We'll go even smaller and look at the microscopic nephron and all the tubes that it will go to before it gets to what's called a renal column or renal pyramid. So, renal cortex, then we'll funnel urine down into this what's called a renal pyramid. The renal pyramid then opens up to what's called your calyx. So this is a minor calyx because it's small. This would be a major calyx where they all come together. It's bigger. So we'll go from your renal pyramid into your calyx, minor and major. Then the calyx will come all merged together into what's called your renal pelvis. So again, urine will go through pyramid, calyx, renal pelvis, and then to your ureter. See if we get into kidneys just yet. Okay. So, and then ureter will go down to the bladder will hold it, go through the urethra, and out the body. So in just a bit, we'll go through all the little sections of the tiny nephron, then end up in the pyramid, calyx, the pelvis, and then ureter. But know that for now. Let's see if I'm missing. Your kidneys are kind of shaped like a kidney bean. They do have an indention right here, just like our lungs had. And that's the same thing, just like our lungs. It's a hilum. It's an indention in the side where we're going to have nerves go in. And we're going to have arteries, so bringing oxygenated blood and nutrients to this kidney. And then so a renal artery feeding the kidney. And then we'll have a renal vein that's taking blood away. So deoxygenated or taking carbon dioxide and any waste products that we'll send out this way. But we'll take blood, unoxygenated blood, back to the heart. Renal papilla, just the small section, kind of the tip of that pyramid. And then you have columns that you can clearly see in between those pyramids. When we open up our pig kidney, you'll be able to see this. You can see it pretty easily. So, blood vessels, nerves, and everything entering in. What is that little indention called? What was it? Yeah, the hilum. So here, there you go, where everything's going inside. Don't stress about this, but you do need to know renal arteries going in, supplying blood to the kidneys, and then coming back out, renal vein. We'll look at those blood supply and look at this in just a second, the nephron. I think it's coming up. There it is. This is the mess. Okay, I told you need to know what structures were found in the renal cortex and the renal medulla. So, Remember, renal cortex is just the crust out here. Renal medulla would be the pyramids and the columns. So this middle part. So the crust is this top part, the renal cortex. So the structures that are found in it is going to be your glomerulus or your Bowman's capsule. Renal corpuscle is all that together. We'll talk about in just a minute. Some tubules. We'll talk about each and every one of these tubules. And then if we get down here, we have just some tubules found in the medulla. And so then we have a collecting duct that will then pour out into that pyramid, then to the calyx, then into the minor and major calyx, into the pelvis, and then into the ureter, to the bladder, out the body. All right, let's go ahead and look at this then. I wish I had the stretched out version of it because it doesn't look so messy. So, number one, let me explain what the glomerulus is. So we're looking right here at a glomerulus, and all it is a bundle, just a big wad of capillaries. Big, huge wad of capillaries. This right here, this renal corpuscle, this little knobby head-looking thing, this is where filtration takes place. So the filtrating unit of the whole kidney is the nephron, this whole structure here. That's the filtrating unit of the kidney. Now, where the majority of filtration, where we're taking everything out, we take almost 100% of stuff out here, happens in the glomerulus. Then, as it starts to travel through these tubules, we'll start taking water back in, we'll take glucose back in. We won't pee all that stuff out. Because normally we filter about 5 liters or so, almost your whole volume here in this glomerulus. So if we weren't reabsorbing that as we go through these tubules, then you would end up dying very quickly. Okay, glomerulus, bundle of capillaries. Another thing you need to be aware of is your afferent arteriole. So remember, back in cardiac, we had arteries, which were big. Then we had arterioles. Then we had capillaries. Then we had venules. Then we had veins. So we had big guys, arteries. Baby arteries were called arterioles. Then we would go into capillaries. Then we would hit a baby vein called a venule. And then we hit a vein. So here you're seeing arterioles again. Come in. This arteriole right here, and this is all still artery, this arteriole going in is bigger than this arteriole coming out. And there's a reason. This is very important. Afferent arteriole is bigger in diameter. It's fatter, wider. More blood can go through it, pump into this glomerulus. On the back side of that, this one coming out, the efferent arteriole, it's smaller in diameter. What is that doing? What's that going to do?
Increase blood pressure.
Does. Because if you have a whole bunch of stuff flooding in and then it funnels down to something really small, all the pressure back behind that builds up and goes way, 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 way up. Because with the nephron, what type of transport are we doing? We have filtration, we have diffusion, we have active transport, passive transport. What's going on here? Filtration. And filtration is passive, but it's powered by what? Not ATP, because it's passive. Powered by pressure, blood pressure. So your kidneys, they are highly reliant on blood pressure. They are a big, big deal when it comes to blood pressure. So that's why some of your early signs of hypotension, you'll see it with your kidneys. You'll see your urine output decrease over time. This is why it's extremely important for you guys to be looking and measuring how much urine that patient is putting out, say every hour or every 4 hours, however often it's prescribed. We'll do, a lot of times in those critical areas, we'll do every hour. We'll measure their urine every single hour. And if that urine drops, say, by 30 milliliters, in 2 hours, each 2 hours it just keeps dropping, then we need to be looking at that blood pressure and make sure that blood pressure is high enough to infuse these, get blood to them. Okay, so afferent going in, big fat blood artery, glomerulus, a bundle of capillaries, and then efferents coming out. So this is all blood flow. And obviously you can see that the kidneys are filtering the blood. Plasma in particular, because that's the water part. So let's get all these capillaries that are wound around these tubules. We call those peritubular capillaries. Peritubular capillaries. And that's it.
That's a cute name.
It is kind of cute. Peritubular
Oh
capillaries.
no, pericarditis.
Okay, so now let's look at what's called the Bowman's capsule. It's what we have the glomerulus with its bundle, and then we have this cup that is sitting over it. And it's got two layers to it, and I kind of showed you here. The inner layer, it's got little porous holes all in it. The outer layer does not. So it'll keep it all in here. So that's just allowing for those particles from that pressure pushing in there to make it through those little filter, like coffee filter holes, into this tube so they can catch it. So what we are really catching is what's going to be the end result, be urine. Right now we call it filtrate. It's what we're filtering out. So filtrate will go from, okay, let me back up. The glomerulus and the Bowman's capsule, all that together, we call it the renal corpuscle. Those two structures together are called the renal corpuscle. So try your best to keep all of that straight, because the questions will ask sometimes just about the glomerulus itself. So you got to know that's the bundle of capillaries. But then other times it'll ask about the Bowman's capsule, which is just the covering around it. And then another time they'll ask you about the renal corpuscle. And that's two of those put together. Makes the renal corpuscle. Both of those things put together will make your renal corpuscle. Okay, so we will start out in Bowman's capsule with the filtrate, which will eventually be urine. It'll travel through this very first twisty-turny tubes, and these are called your proximal. So what does proximal mean? What does proximal mean?